Hello class, this is Mrs. Albritton of Albritton's math class, AMC. So today we're going to take a look at the practice test / study guide that you were given in order to prepare for our unit test on right triangle trigonometry. So let's start with number 1. We'll do number 1 through 5 on this first video. Number 1, so here we have our diagram, and it says that the legs of the right triangle A, B, and C measure 5 inches and 12 inches. And the hypotenuse measures 3 inches. So let's keep in mind, we know that in a right triangle we have a leg here and a leg there, and the diagonal is going to be your hypotenuse. Also, the hypotenuse is always the side that is directly opposite the right angle. The right angle is designated in this little box. All right, so the question is, what is the value of the cosine of A? Now, of course, what you need to recall is that we have 3 trigonometric functions that we've been working with. We've been working with sine, cosine, and tangent. So remember the mnemonic device SOHCAHTOA, and what that reminds us is that sine, so when we see sine, that means opposite over hypotenuse. Ka means cosine, adjacent over hypotenuse, and the TOA is tangent, which is the opposite side over the adjacent side. Now we're actually finding the cosine, so we're looking for this part right here. So for cosine of the angle A, remember they're going to specify which angle they want you to look from. So you're looking from this angle right here, angle A. But cosine of angle A is asking for the adjacent side of angle A over the hypotenuse. Now the hypotenuse never changes, it's static, so it stays in the same place no matter what angle you're looking from. The hypotenuse will always be the hypotenuse, and it's always the longest side. In order to determine this, since we're looking at the cosine from angle A's perspective, then I need to look from angle A, and I look for, first of all, the easiest thing to find is probably the hypotenuse, the 13 inches, which goes on the bottom. And then the side adjacent is 5. Now, why is it not 12? Because 12 is opposite that angle A, or across from it. So we can't use 12. So we're looking for cosine of A is 5 over 13, which is choice A. Okay, now since we can see number 3 already on the screen, let's go ahead and move to number 3, and then we'll look at number 2. So number 3 is a similar type problem. So here this time we have another triangle, a right triangle that's ABC, and it measures 4 centimeters and 3 on the legs. So here's 3 and 4 for the legs, and then the hypotenuse is 5 centimeters. Now let's see what we're asked for on this one. Here we're asked to find the value of tan, the tangent. And remember, if you use the mnemonic device SOHCAHTOA, it's going to help you to remember that tangent is the opposite side over the adjacent side. So we are looking for the tangent of, again, angle A, and it is going to be the opposite side. This is the ratio we're looking to set up over the adjacent side. So we're talking about opposite of angle A, and again, here's angle A. The side that's opposite that, or directly across from it, is this side. So when we're doing the tangent of angle A, the opposite side is 4. The adjacent side, which is right next to angle A, is 3. Because keep in mind, this is the hypotenuse, and the tangent does not have anything to do with the hypotenuse. So we're looking for 4 over 3, and that is letter D. Okay? Let's take a look at problem number 2. So problem number 2, in the diagram of the right triangle ABC below, what is tangent C? Okay, we've already talked about the fact that the tangent of whatever angle they're referring us to is the opposite over the adjacent. So we are going to look for these sides. And how do I know this? Because of SOHCAHTOA, the TOA, tangent opposite over adjacent. And we're told to look from angle C. So you gotta be careful that you're looking from the angle that they specify. Otherwise you could get the wrong ratio. So when I look from angle C, the tangent of angle C, opposite C, which is directly across, is 2. And the side that's next to C is 3. Now, I know that the hypotenuse is next to C also, but it's the hypotenuse. And they're not asking for the hypotenuse on tangent. So the answer is 2 over 3, which is the letter C. Let's take a look at number 4. So here's problem number 4. In the diagram of triangle CDE below, the measure of angle D, that's what this denotes, measure of angle D is 90 degrees. The measure of angle C is 28 degrees, and the side ED is equal to 15 inches. Which equation can be used to find the length of segment CD? So what we're looking for is this side length. So I'm gonna go ahead and call that X because that's the unknown side. Now in this case, I don't have enough information to use the Pythagorean theorem like we've done with some of our problems like this, because all I'm given is just one leg. I don't have the hypotenuse. Now if I had the hypotenuse, I could have just used a leg and the hypotenuse to calculate the missing leg, but I don't have that. But something else I've been given the angle measure of C is 28 degrees, so we can use that. So the first thing I need to do with the given angle of 28 degrees is, from that angle's perspective, find out which of the 3 trig ratios do I have information on. So when I look from angle C's perspective, I see that I do have something that's directly across from it. So I have an opposite side, and I have this adjacent side. Now I don't know what it is, but I've already put in a variable to denote or be a placeholder for the actual value. So I have opposite and I have adjacent. That means I'm gonna go ahead and use that information. Now, opposite over adjacent, remember that's tangent. SOHCAHTOA, tangent, opposite over adjacent, which tells me I'll be using the tangent function. And I'll be using the tangent function for angle C, because that's what I've been given. But since C has an actual measurement, degree measure, I can go ahead and put 28 degrees here. So the tangent of angle C, which is 28 degrees, is gonna be the opposite side over the adjacent. Okay, so I'm gonna write tangent of 28 degrees is equal to, well, what is that opposite side? It's 15. What is the adjacent side? That's the unknown where we filled in the variable X. If we solve this, we will be able to isolate the variable X and get an answer for it, a value for it. But the question asks which equation. So they didn't ask us to solve it, they just want us to set up the equation, which we have done. So we're looking for tangent 28 degrees is equal to 15 over X. Now, if you look at the answer choices, instead of putting X, they just kept it CD. Because remember, segment CD, I set it up as X just so we can see the equation, but we're still looking for this particular answer. 15 over segment CD, tangent. Okay. All right, and then to end this video, we'll do number 5. In the accompanying diagram of right triangle CAR, the measure of angle A is 90 degrees. The measure of angle C equals 59 degrees. And the side CR is 15. So this is similar to number 4, because here, if AR is represented by C, so this time they give us a variable to represent that line segment. Which equation can be used to find C? And again, the first thing we have to do is look and see, do we have enough information to find side C with using the Pythagorean theorem? Because that's probably the easiest way. We don't have enough information for that. But what we do have is we have an angle measure right here, 59 degrees from this particular angle. So we've got to determine which of the 3 trig ratios do we have information for, and that's the one that we'll use in our equation. So looking from the given angle measure, I do see that there's something opposite it, and that is C. So we have an opposite side with some information, even if it's just the variable. And then we have the hypotenuse. So opposite over hypotenuse tells us that we are using the sign. Remember SOHCAHTOA? So is the sign opposite over hypotenuse. So this must be sine. And it's from this angle, 59 degree angle. So This is what we'll be looking for. Now, in this case, they want us to go ahead and fill in what the values are, or the variable, if we have one, which we do. So sine of 59 degrees is equal to the opposite side, which is the C that they gave us, over the hypotenuse, which is 15. So this equation will help us find the value of C if we solve for C. And that one actually matches, well, this is cosine, so it's not that one. This is tangent, it's not that one, so it's one of these. But look at the angle measure, 59 degrees is C over 15. So this is the equation that we would use in order to find the value of C. All right, let's take a look at number 6 through 10.